In this video, we're going to learn how to create positional representations inside of Autodesk Inventor. Here I have positional reps 1 IAM and positional reps 2 IAM from our working files directory. Here in our first example, we want to create a positional representation that showcases this little arm that it has in a different state. So I can document this on a print to show the fully open versus fully closed scenario, as well as perhaps utilizing this in an IPN file or in a higher level assembly to utilize the open or closed state of this particular motorized gripper. Now, the first thing you want to consider when you're working with a positional representation is you have to set up your assembly just right. You have to make sure that you have a constraint that when modified through its range of travel does not become invalidated for the purpose you want to have. For instance, when I originally built this gripper, I had used some rotational constraints to control these gears and how they go together. But when I try to control that with my positional representation, what ends up happening is one of the fingers on the gripper will actually flip around the opposite way based on how I put this together originally. So I might have to work through my positional representation to either suppress certain constraints or override other constraints. In this particular case, I went ahead and just suppressed those and create a new constraint that I'm going to work with here. That constraint is down below under Vex Claw Finger Occurrence 2. It is called Flush 6. It's currently set to 40 millimeters. Now, if I come in here and modify this to 0, it will close up my gripper so that they are touching each other. If I change it to something like 42, then it opens up to the open state again. This constraint is essentially half of the value of the open condition. In order to make it easier for me to understand, I might come in here and rename this. So if I right-click on the constraint and choose Edit, I can give it a name in my expanded part of the constraint box here. If this was not exposed for you, make sure you click on these chevrons to expand that. And I'll call this one half opening. And it essentially has an equation set up so that the other constraint also adjusts it the same way. Now, how do I create a positional representation to showcase this closed and open? Well, if I go to the top of my browser and expand the representations node, I can see I have my 3 standard representations: view, position, and level of detail. Right-click on position and choose new. Expand the plus sign in front of your new position here, and do a soft double-click on the name to give it something more intelligent. So here my new position will be a closed position, so I'll type that in. Now, how do I override this to be in a closed state? Let's go find that constraint again, the half opening one. If I right-click on this, I now have a new set of options here to work with this constraint. I can directly modify the offset value by choosing this option that's currently highlighted called Modify with Override in parentheses. I can do a suppression in the same way. And I can also go to this Override option to see a dialog box of different things I can adjust. Here I'll choose the Override. In this dialog, I have 3 tabs: Relationship, Pattern, and Component. Now on Relationship, I can control the suppression and the value of this particular half opening flush constraint. This also works for joints. So if you had a cylindrical joint, a rigid joint, you can offset your linear and angular settings for all those different degrees of freedom. We're keeping it pretty simple here with a standard flush constraint. And for the value, I'm going to override that. So I'll choose the value toggle and change the value from 42 to 0 millimeters. Now, just to take a look at the other elements of this dialog box, you can see there's also pattern, which controls rectangular and circular pattern values and offsets. We also have the component to control a grounded state, a position offset toggle, flexible status, and if you want to create nested positional representations. Since I'm only looking at a relationship, the only thing I can really adjust is on this first tab. If you were to right-click on a pattern or right-click on a component, you get different settings for those different options. So here I'll choose OK to create that positional state of that gripper being closed. Now you can also see that it created the half opening in a bold condition. So down here it looks like it has half opening in a darker font. If I scroll up to my position representations, I can double click back and forth between master and closed. So very quickly changing between two different states. Now this was a very simple example of just one relationship being modified. However, I could create a condition where it has multiple constraints overridden, multiple constraints suppressed even. You can do a lot of different things inside of your positional state. You don't have to do just one thing. Now, if I want to create a nested representation, we'll do that over here on our second file, Positional Reps 2. So here I have a stapler, and this stapler actually has a positional representation inside of it already. It has master in position 1. If I double click on position 1, you can see it basically opens it. You can see upper 1 is in an overridden state, and if I expand that, you can see the stapler hinge angle is set to 90 degrees on this. Now, if I look under the representations for this, you can see the position is currently in an open state as well. How was this created? Well, I can delete these and work backwards. So if I go back here to master at the top level and delete position 1, I'm going to create a new positional state at that top level. And instead of just position 1, we'll call this one open. Now to override upper, so I can get into this open positional rep of the upper assembly, simply right click on that and go to override. On component, I'll choose positional representation for the upper IAM and choose that to be in an open state. I'll apply that. You can see it opens up that particular item. Here I'll cancel out. And now I will go to my stapler hinge angle, right click on this and do a modify override. As you can see, you can modify it directly right here. I'll change that to 90. So there you can see I have a nested positional representation where it takes a subassembly, puts that into a positional state, and also allows me to override the elements that interact between there. So to recap what we learned here, we can create positional representations at the top level of our design that can affect subassemblies and their positional states and how they interact together. We can modify constraint values. We can suppress constraints. We can also turn the flexibility of components on and off of our subassemblies. For instance, you can see in my tree on the left-hand side, I have a channel subassembly that is currently set to flexible. I could go in there and override that, make it not flexible for this positional representation, or enable that flexibility. Also, change the settings for a rectangular pattern or a circular pattern through this. So this has been a look at how to create positional representations inside of our assemblies.